So this is a million-dollar question, isn't it? We see an AI do something perfectly one time in a demo, but when we try to build a reliable, repeatable process around it, the whole thing just becomes a messy, unpredictable, and ultimately useless mess. What is going wrong?
First up, we had expert systems. Now, you can think of these as gigantic, complex, if-this-then-that rulebooks. They were perfectly stable. They did exactly what you told them to every time. The problem? Well, the real world is messy. The second these systems ran into something they weren't explicitly programmed for, boof. They just shattered. They were stable, but incredibly brittle.
So the next wave, machine learning, was the complete opposite. It was amazing at learning from messy, real-world data. It could handle ambiguity. But it came with its own new, massive problem. You couldn't really control how it made decisions. It was a black box. So it was super flexible, but totally uncontrollable.
And that brings us right up to today with large language models. These things are incredible. They can reason and understand language in ways we only dreamed of. But ask one the same question 5 times, and you might get 5 completely different answers. They are unbelievably intelligent, but they are fundamentally unstable. And here's the perfect way to think about it. It's like a good recipe for baking a cake. You follow the steps, you get a cake. Now, one cake might be slightly different from the next, sure, but the core steps, the structure, the fact that you end up with a cake, that's consistent.
How do we build a prompt that actually creates this kind of stability?
The answer. This is the elevator pitch for the whole idea. Think however you want gets you creative but unpredictable results. That's great for a brainstorm, but it's terrible for a business process. Think in this order gives you a reliable, repeatable asset that you can actually build a system on top of.
So when you take that procedural spine and you combine it with a few other key structural elements, you get what's called an expert lens. Think of it as the complete package. It's a prompt that's been transformed from a simple question into, well, a mini program for AI reasoning.
So what's in this expert lens? Well, it's got a few key ingredients. You have to anchor the AI in a specific role, you align it on the key concepts, the ontology, you give it that procedural spine we just talked about, and you tell it exactly what the output should look like and what success even means. And the productivity gains you get from this, they are huge. First, you get to reuse these prompts instead of constantly reinventing the wheel. Second, your team can stop micromanaging the AI and just tell it what they need. And third, and this is a big one, because this is about structure, not some secret sauce in one model, these prompts are way more robust. They work consistently across different AIs like GPT, Claude, or Gemini.
Why does this approach, this combination of declaring the goal and enforcing a thinking process, why does this finally work where everything else has failed? This table is super cool because it shows that this isn't some idea that came out of nowhere. It actually pulls together the best parts of all those previous eras we talked about. See that procedural spine? It's like the powerful logical engine from old school AI. But now, instead of needing a PhD in computer science to use it, any of us can guide it with plain English. It connects all the dots.
And you know what the best part is? This is what we call frugal innovation. You don't need to go out and build a new multi-billion-dollar AI model. You don't need to spend millions on retraining. You're just changing how you talk to the models you already have access to. It's a really low-risk, super high-impact change.